All right, today we're going to be looking at topic 3. There's a 2-day topic, solving exponential equations. So this would be equations where the variable is in the exponent and we are going to solve for the variable. 3-step process. You have to rewrite both sides of the equation using the same base. Set the exponents equal to each other and then solve. Let's take a look at number 1. 2 to the x plus 1 is equal to 8. So the first thing we do is we got two sides here. The left side has a base of 2, the right side has a base of 8. First thing we want to do is express both sides using the same base. So in this case, the easiest base will be the one we already have, which is 2. The left side is already expressed using a base of 2. We want to express 8 using a base of 2, which means what exponent would we have to give to 2 in order to get 8, and we would have to raise it to the third power. So we can express 8 as 2 to the third power, because 2 to the third power is 2 times 2 times 2, which is 8. So those are equivalent. Now that the bases are the same, they're both 2, that implication here is that the exponents must also be the same for these equations to be equal. So now we can just set the exponents equal to each other. X plus 1 is equal to 3. And solve this equation. Minus 1, x is equal to 2. So this would be our solution to the original equation. And you can check to verify that this is the correct solution by plugging it into the equation. So 2 to the x plus 1, so 2 to the 2 plus 1 equals 8. That's 2 to the third power is equal to 8, which is 8 is equal to 8, and that is correct. 8 is equal to 8. So 2 is our solution, and we've also verified that 2 is our solution. And this is the process. Problems get a little bit more difficult, but it's the same process. Number 2, 4 to the 2x minus 1 is equal to 256. So first we figure out a base that we can express both sides using. The left side has a base of 4, the right side has a base of 256. I'm going to see if I can use 4 as a base for 256. So I need to figure out what power can I raise 4 to get 256. I can use a calculator to do this. So 4 times 4 is 16, times 4 again is 64, times 4 again is 256. So I would have to multiply 4 together 4 times. So this would be 4 to the 4th power. 4 to the 4th power is 4 times 4 times 4 times 4, and that's 256. So I can rewrite 256 as 4 to the 4th power. And this is what I want. I want both of these bases to be the same, 4 and 4. Once the bases are the same, I can now set these exponents equal to each other. 2x minus 1 is equal to 4. And this is a two-step equation to solve for the variable x. I would have to add 1. 2x is equal to 5. And I would have to divide by 2. Whoops, that's not what I wanted. So our solution, x is equal to 5 halves. And this would be the solution that makes this equation true, plugging in 5 halves for x. Number 3, we have 5 to the 5x is equal to 125 to the x plus 2. All right, so the idea here is the same. It's just there's going to be a little bit more math involved for us to do this one. So first I decide on a base. I have a base of 5 here and a base of 125 here. I'm going to see if a base of 5 works. Okay, so I'm going to figure out what power can I raise 5 to get 125. So I'll just start multiplying 5 together. 5 times 5 is 25, times 5 again is 125. So I would have to multiply it together 3 times. 5 to the third power, 5 times 5 times 5, which is 125. So I can rewrite 125 as 5 to the third power. Remember, it already has an exponent, though, of x plus 2. Now, this is where you have to remember a property of exponents. This is called the power of a power rule. And the power of a power rule says that if you have an exponent on a base and you raise it to another exponent, then the new exponent would be these two multiplied together. So it would be 3 times x plus 2. Don't make the mistake of just multiplying the 3 by the x, because we can see here that this 3 actually needs to be distributed to both of those. So it would be 5 to the 5x is equal to 5 to the 3x plus 6. We have now successfully made the bases into the same number, which means that the exponents also should be equal to each other. So we can set up the equation 5x is equal to 3x plus 6, and we can solve this for x. Move the variables onto one side. So 2x is equal to 6, and then solve for x by dividing by 2. And we can see that our solution to our equation is 3. And then number 4, 27 to the x minus 1 equals 9 to the 4x minus 3. And this one is a little bit more challenging because the base of the left side is 27, the base of the right side is 9, and we can't express 27 with a base of 9, and we can't express 9 with a base of 27. So we're going to have to use a new base that's different from 9 and 27. And it turns out that a base of 3 will work because 3 to the second power, 3 times 3 is 9, and 3 to the third power, 3 times 3 times 3, is 27. So I can express 27 as 3 to the third power, to the x minus 1, and I can express 9 as 3 to the second power, to the 4x minus 3. All right, I have to use power of a power rule here because I have two powers, so they need to get multiplied. Which means for both of these, we are going to have to distribute. So you got 3 to the 3x minus 3 equals 3 to the 8x minus 6. And now we have successfully made the bases the same. Both the bases are now 3, which means that I can make the exponents the same as well. So 3x minus 3 is equal to 8x minus 6. This is variables on both sides problem, so I'm going to start by getting the variables on one side. So I'm going to move this 8x to the other side by subtracting it. So negative 5x minus 3 equals negative 6. Solve for x, so add 3. Negative 5x is equal to negative 3. Divide by negative 5. Those two negatives are going to cancel out and make a positive. So I'm going to have x is equal to 3 over 5. All right, so x is equal to 3 over 5? Sure. Why not? Yeah, yeah, looks good to me. All right. All right, so homework, page 93, numbers 1 through 6.